So speed of the wave, part one. I know that speed is distance over time. So if I have a wave that is traveling along here, well, think about that. A wave is created, if say I have a long coil, it's created by moving it back and forth, and it's sending a wave. So in the time it takes me to create one wave, the change in time is the period. Well, how far has the wave traveled in the time it takes me to create a wave is the wavelength. So the distance in one period is equal to the wavelength. So in essence, the speed of a wave is equal to the wavelength divided by the period. Well, I know that the period is the reciprocal of the frequency, and so therefore 1 over t is equal to the frequency. So the speed of a wave is equal to lambda times 1 over t, which is lambda times the frequency. So any wave that has repetitive motion to it, the speed is equal to frequency times the wavelength. Now I do want to point out, I can't remember if this is another video or not, is that sometimes you'll see a different symbol for frequency. This is the symbol that I will be using, but sometimes books will use the letter nu, which looks like that. And so this equation, if you're looking at another source, would be V is equal to nu times the wavelength. And so you suddenly have these two symbols that look alike. Now sometimes the font, depending upon the font, I have seen it look like this, because that's the font that the book uses for nu, and that's what they use for V. And so this is why it's really confusing to be using nu. And so one of the things I do is when I go and look at a textbook is I go to find this equation right here, just to see what their symbol for V is and what their symbol for nu is. I'm really not a fan of that, but there are a lot of sources that use that. So this is the formula we're working with right here.